Okay. All right, so first bit of introduction here is low. Sorry about the evil. Correction credit, measure that angle, figure out what angle of that declination is. Second, there's actually two sides to this. See, this to me should really be all in one day. It's really not that big a deal. But the book breaks it into. So I'm going to teach 76 today, which is integrating even powers of trig. And later on, shucks. Would you change set 83 side to integrating even powers of trig? Set 76 should be odd powers. Set 83 should be even powers. Set 76 should be odd powers. Set 83 should be even powers. Rather than do two separate papers, I just thought I'd put them together. I'm just going to do the front. It won't take very long, the set 76 piece, and then just hang on to this paper so that when we get to set 83, you can just use the back side. In terms of notes, in a notebook, you'd want these two together. Okay? All right. So here's the idea. You're going to integrate sine Q in a second. But just as a way of reminder, there are two identities you might consider as we go. Sine squared is equal to 1 minus cosine squared. That is actually a form of the big identity called the Pythagorean identity. The other is cosine squared is 1 minus sine squared. Both coming from sine squared plus cosine squared is 1. Yeah? Are you with me?
Yeah.
Okay. Now, keep those in mind as you consider how would I integrate sine Q. Factor it out. Okay, how would you factor it out? Sine of x times sine squared of x, okay? Okay, good deal. That's a product. Is that a good use of candidate? Not a good use of candidate because one's not the derivative of the other. So what did I do?
Change the sine squared of x to 1 minus.
Yeah, we use that identity, so sine squared becomes 1 minus cosine squared. All right. And then what?
Make the answer.
Cece, go. Okay. For the whole thing, or split it up?
Split it.
You're right. Okay. You want to split it up first, and then you're going to use up part of it, not all of it. All right. So you're going to go sine of x dx minus cosine squared sine dx. I distributed the sine and the dx and split it into two integrals. You see where we're coming from?
Yes.
Okay. Now the first one is then just your basic integral, cosine or negative cosine? Negative cosine, okay. The other part is a use of. So now, as Cece already started us off, we're going to let u equal cosine and du be negative sine. So that with that substitution, I guess I'm going to borrow that negative and call it plus u squared du. Do you see where we're coming from, or do you agree?
Yeah.
Okay. The antiderivative of which is 1/3 u cubed. In the interest of saving space, I'm going to do that and sub back with 1/3 cosine cubed plus. All right. Now, you probably could have figured this all out on your own, so I'm going to brush through it pretty quick. But the big idea you can say is if you have, where should I put this notes here? should have put this in a box, sorry. If you have an odd power, you split off a single to the first, and this will become your du later on, okay? Use an identity for the even power that's left. Does that, do you see where I'm coming at? You see what I'm saying? We split this cube into sine and sine squared. This sign you'll later see will become a du. For now, just think of it like, all right, I replace the even powered stuff with an identity. When you do that, you'll get the other trig function and you've got this u du situation. You with me? Try this one on your own with a coefficient of x. I'll let you play with that.
Wait, which one did you try?
The right.
Okay.
Please. All right, ready? Sorry, I'm slow. Okay, I had something like 1/4 sine of 4x minus 1/12 sine of 4x cubed. Should we go through it? Okay. So what's the first thing you did? Split it into cosine of 4x and cosine squared of 4x. Okay. This will be your du. Don't sweat that now. For now, use the identity on the square. So it becomes 1 minus sine squared of 4x times the cosine of 4x that was stray and left off to the side. So far, so good? Okay, if you distribute, then you'd have cosine of 4x, that integral, minus another integral of sine squared 4x cosine of 4x. All right, on this, did you actually use sub or just kind of mentally deal with the 4? Okay, sounds good. So in my mind, what goes on is if that's u, then I would like du to be 4 dx, so I could put a 4 there and a 4, whatever. However you deal with it, whether you actually use sub or you do that kind of mental, how do I make the du there and balance it, whatever works for you, do that, okay? This one is so hairy that I use stuff. It's just too much for me. So I let u equal sine of 4x. Therefore, du is cosine of 4x times 4 dx. Yay? So that when I make that substitution, sine squared becomes u squared, and the cosine 4x dx would actually be equal to du over 4. Yay? Or 1/4 du. So that when I integrate that, u squared's antiderivative is 1/3 u cubed, altogether making a 1/12 u cubed, and then subbing back because I'm out of room with sine of 4x all cubed. Yeah? Are we cool? Okay. All right then. A little variation. What about cosine to the 5th? What do you think you do? Let's just see where it takes us. Split it up into cosine to the 4th, cosine. You are on the right track. Do that. Then what? What's that? Yeah, cosine squared. I guess I could have even gone this much. To use the identities, I need to go all the way to this place, yeah? Mm-hmm. All right, so that would give me 1 minus sine squared, 1 minus sine squared cosine. If I distributed that, I'd have something like 1 minus 2 sine squared plus sine to the 4th of cosine with a cosine out there. Yay. Let me give myself a little more room. Okay, so now I'm going to get 3 integrals. Cosine x dx minus 2 sine squared cosine dx plus sine to the 4th cosine dx. Wait. What's the antiderivative of cosine? Sine. What's the antiderivative of sine squared cosine? Let's not use that. Let's just mentally use that. What would your u be? Sine. What's your du? Cosine. So you have perfectly set up u squared du. So the antiderivative is 1/3 sine cubed. Right?
Yep.
Okay. The next one, if we use subbed it mentally, what's u? Sine. What's du? Cosine. So I would have u to the 4th. What's the antiderivative of u to the 4th?
1/5.
1/5 u to the 5th, but instead of u, we'd have. Okay. Cool? Try the next one on your own. See if you can work through the issue to that one. The rule is you focus on the odd. That's the one that you take one off of. Never take one off of the even power. Go to the odd one and strip a single off the odd. How we doing?
Done.
Okay. So I split the sine cubed into sine squared times sine, and then replace the sine squared with 1 minus cosine squared. That's where my first step is coming from. Follow? If you, I'm distributing from both sides. So cosine squared sine and negative cosine of the fourth side. Yay? If you formally use sub, then you can do that. I'm going to kind of think my way through this. What's your u here? So it's du. Negative sign. So in my mind, I think, well, I want this to be negative sign, which I can make that as long as I balance. This then, in essence, is negative u squared. So the antiderivative is negative u cubed over 3, right? And u is cosine. So for that first one, do you have something like negative cosine cubed over 3? Yes? Right. Now, if that doesn't work for you, that mental stuff, do the u sub on paper, and that's fine. So how does this one work out then? You pick up a negative, same thing, except it's positive and 1/5. Okay? And it doesn't matter if you put the exponent outside parentheses or on the cosine. We cool? Okay. What? Did I make a mistake?
Just put it together.
Oh, so I did. You're right. Okay, that's better. Okay, last one. Yep, sorry.
Why do you not substitute for cosine?
I could. It's too much work for me. I did it mentally, basically. I did use sub it. It's just. Oh,
No. Like, why did
in this, not here. Here? Why did I not break that into pieces?
No, like, why didn't you do 1 minus sine squared?
Oh, I see what you're saying. I could have. The problem is that would be then eventually 2 odd power of trig. Oh, actually, you don't. Oh, yeah, sine trig, right? At that point, if you do that, then you're going to have to do that splitting off thing and replacing with an identity later, but twice over. And so that's your question. It makes it worse. It'll get you there, but it'll make it worse. Okay? So you should always focus on the odd power, break it down, and replace the even part of it with identity. It'll always go cleaner that way. Okay. This one then, the question is, well, which one should be split out? It really is your choice. You could, because they're both odd, you could split off a single cosine here or a single one here. Which one do you want to use though, sine or cosine? Sine would be easier because it's closer to the square. Once you pull it off, then you've got your identity, whereas this would be cosine to the fourth, and you'd have to break it down into cosine squared, and it becomes a mess, right? So although it would work both ways, I definitely think the quickest way would be to take the smaller one, break it up, replace the sine squared with 1 minus cosine squared, and you'll get there quicker. Do you see where we're headed? Should we finish, or do you see where we're headed? We good? Okay, let's finish. So the next term would be 2 integrals. What are the 2 integrals? Cosine of the 5th sine and net minus cosine of the 7th sine. All right. In terms of u sub, whether on paper or mental, u is cosine, so du is negative sine. So this is a case where you'd like a negative and you bring in a negative. So the antiderivative of that first one is negative 1/6 cosine to the 6th. Okay. What about the next one? Let's do 1/8 cosine to the. Okay. All right. From experience, those tend to go well. Students tend to do fine with those. As I said, the back of those will come back to those backside notes when we get to 73, so just leave those till later. All right, questions on homework. Let's get caught up. We have about a half hour. Let's get all the way caught up.
Wait, what?
All right, or not. 70 what, 2? Okay, 72, 3 or less questions. Come on. How many?
I had that in yesterday.
I didn't do it.
Also, there wasn't a key for 72.
Yeesh me. What do you need a key for? It's all up
I want to
there.
check
Ask
my
Izzy.
work.
Ask Izzy.
I turned it in yesterday.
Oh,
I thought that it was due on Monday.
ooh. 72 replacement problems. A, did you get the amount at any time, number of people, whatever you want to call it, is from 0 to t of e to the x minus l to the, or l of x, the x. Plus 10 plus the initial condition, right? Okay, plus 10. How many you forgot the plus 10? All right. Is the number of people in the store increasing or decreasing at time 4? So, there's a fancy-pantsy calculus way to do this and a more common-sensey kind of way. The fancy-pantsy calculus is to say increasing if n prime is positive and decreasing if n prime is negative at time, what time is it? 4. And that'll work. What is n prime? E to the t minus l of t. So greater than 0, doesn't that get you to common sense land eventually, which is to say the number of people will be increasing if the rate at which they enter is greater than the rate at which they leave. Common sense. Okay? Vice versa, or otherwise decreasing if enter is less than leave. So you really need to gather the evidence. What is enter at time 4 and leave at time 4, either separately or together, and make the conclusion. E at time 4 was 2.6. L at time 4 was 1.385. So because E at 4 is greater than L at 4, in other words, people are leaving at a faster rate than entering, then we conclude decrease. Decreasing? Isn't entering greater? Why do I just listen to? Why do I listen to? You just still felt compelled to answer, huh? Even though you have no idea what you're talking. All right. C. About C then. What is the max number of people? Is that absolute max or relative? Absolute. Absolute max must be at critical numbers or endpoints. The endpoints are at times 0 and 6. The critical points are at when the rate of change in the number of people, so that's m prime, which equals E minus L equals 0, also known as where the enter rate and the leave rate are the same. That's where they're equal is a possible candidate, and then before and after them, we have to say, did it go from entering greater to less or whatnot. So your candidate there is at time equal 2. This happens at 2.245 and 4.456. Do you agree with Harmony? Yes? Okay then. Way to go, Harmony. You're a champ. N at 0 was 10. N at 6. 0.318. I'm using my n function, by the way, to make this calculation, or at least Harmony was. N at 2.245 was roughly 0.5. By the way, I just kind of made this up on the fly, so if the answer doesn't make sense, that's...
Yeah,
Okay, it's not a very good store, basically. 3.45, yeah? 1 or something like that? So what's the max number of people in the store?
And
Yeah, 10 at the very beginning, and then people just started leaving or something.
maybe it's like the employees come in at the beginning of the day and then they walk out because there's no one else in the store.
Yeah, yeah, it's so busy, it's, exactly, that's what I thought the whole time. It's so dead today, everybody go home. That's what happened. You bet. The max number of people, does it say when is the max number or what is the max number?
What?
So the max number is 10, because that's the greatest of the candidates. 10 is greater than 3.451, greater than 0.5, greater than, so, right? Okay. Hold on. How about 18? The derivative of absolute value. Hi, what? Here's my life. Everybody say hi, Mr. Franklin.
Can you write river check sheet? I have a checkbook.
Sure. Are you supposed to do that?
I don't know, she's taking up.
Okay, sorry.
Don't bother your parents.
Yeah, don't bother your parents while they're at work. I think they're the center of the universe. You're supposed to just drop everything. Whatever. Where did I leave off?
18.
Oh, yeah, sorry.
You were taking the derivative of the absolute value.
Absolutely. Okay, cool. Do you remember? I haven't gone back to this nearly enough. I was kind of relying on the book giving you practice. Do you want a refresher or just the answer?
Refresher.
Okay. So the idea is that you write this as a piecewise function. I found it easiest to do this graphically on visual. So you have a cube with zeros at 0 and 1. You know the shape could be,
How did you take out the x squared from the x?
just making sure you're paying attention. Way to go. Okay? So as I said, good job. You passed the test. All right. You actually have a cube with 3 zeros or 3 roots and attaching the appropriate shape that looks like that. It is not function, by the way. There should be symmetry with yours. Are we cool?
Yep.
Okay. What does the absolute value then do?
It flips everything that would be negative.
All right. So we have this.
So, won't be double.
Yeah, funky. Now, if I say this as a piecewise function, then any piece that was positive-wise didn't get changed at all, and so it's exactly the same. So I could say that that second piece from -1 to 0 is exactly the same. X cubed minus x, the absolute value was nothing. And likewise, the far right piece from 1 to infinity was unchanged. You with me?
Yep.
Okay. What about the pieces that did get flipped then? What's the equation for them?
You just put a negative in front of it.
Yeah, put a negative in front of it, so now it would be negative x cubed plus x from negative infinity up to -1. And negative x cubed plus x from 0 to 1. Now, make sure the endpoints are included on one or the other branch because it is defined at those points. You with me?
Yep.
All right. The derivative then is the derivative of each piece, and then just being careful at the endpoints. What's the derivative of the leftmost branch?
Negative 3x squared plus 1.
And that's for negative infinity up to -1. The second branch.
3x squared plus
And that's from?
-1 to 0.
All right, so why don't I include those endpoints then?
Because it's not differentiable at those points because it's a sharp.
Sharp turn, it's not differentiable at those points. So you should not be including those in the derivative. Negative 3x squared plus 1 from 0 to 1, and 3x squared minus 1 from 1 to 1. You follow?
Yep.
I should have given you more practice. It's not hard, but you do need a little. Yeah.
So I understand how to do it when you can like look at the graph, but I don't understand how to do it like analytically.
You're right to think that. So if you don't have the graph and you don't have your calculator, then it involves, you have to set the function within, set the function, not the derivative, equal to 0, find the possible places it's flipped, okay? Then you would sign test within those places to see what was positive, what was negative, to help you write the piecewise. All right, now, 90% of the time, 99% of the time, you'd be covered. If the teacher or the professor is really a gotcha kind of professor, it is possible that it's smooth at one of those places. Excuse me. So that if it got flipped up, it would still be smooth. And so, whereas we normally don't include the endpoints on the derivative, because there's a sharp turn there, in that case, that point would be included because it is differentiable there. So if you are worried about the gotcha, or if you saw some kind of maybe no sign change in here, I would then go to the derivative and see is it differentiable. Does that make sense? It is much harder. If I gave you something hinky like f of x equals e to the x squared sine or something like that, it's much more complicated like you're talking about. Okay? Maybe I'll try and get you a practice that's not too bad. That's a good question. Thank you. 72 other questions. 25. That must be a honey. That's a lot of questions. Sure. Harmony, what's the answer for 19?
Yeah, wait, hold on.
If I were a girl, I would do that all.
Mr. Rick.
Yes. Just a second, actually. Hang on. 19. The answer, according to Harmony, is 4x squared plus 1 and a 2 in the numerator. Do we all agree?
Yeah.
Okay. Harmony, you can. There you go. What would I do with that?
So my problem sets didn't have a bad side that you printed, so I didn't print this off from at home or just picked it up and do that.
Anybody else get a 72 without a bat?
Or am I the only one? So I was like,
You
oh,
might have got my original.
because I was like super excited. I'm like, oh, it just needs the other.
So it's just you, but you took the initiative and you printed it the back off, or you said, "Ooh, no back."
I said no backside.
Let me think about what to do. You have done these already, so that's 25. You said, yeah. Okay. All right. 25. How are those work or force problems going, by the way? Good? No. I think that answers the question, but I understand what you're saying. No. Just no. Absolute max, y equals max.
Yeah, that's just a because I really mean.
Okay, this is a really good question. This kind of goes to, one of these guys asked about it yesterday, about absolute versus relative and how to word it. So this is, I'm glad you asked, this is great. And actually the second derivative test doesn't prove this very well. It's really the first derivative test that will. Gosh, okay, so here we go. Let's start off with the derivative. I assume the derivative went fine. Plus e to the can I, if you had trouble with second derivative, you're going to, I can't remember what's said, but eventually you're going to take dozens of derivatives of e, and if you constantly refuse to factor as you go when you get to tabular integration, your life is going to be terrible. This is what I mean then. Don't take the derivative here. Take out an e to the negative kx and call it negative xk plus 1 before you take your next derivative. That's actually still the first derivative, sorry. It's gonna get ugly. You're gonna go from 2 terms to 3 terms to 4 terms. It's factor. So y double then, first stays the same. Actually, I need to pause. Slow down there, Johnny. The second derivative test works in such a way that I have to find where the graph goes flat, then test concavity at that point, okay? So where does this go flat? 1 over k. Oops.
Negative.
No, I think you're right. It's positive. Positive 1 over k, right?
Yeah.
Okay. Okay. So that's a place where the derivative is 0. We have a horizontal tangent. Now, let's go to the second derivative. First stays the same. Derivative of the second is negative k, plus second stays the same. Derivative of the first.
Yes.
If I pull out a greatest common factor of negative k e to the negative kx, I'm left with 1 minus xk plus 1, or negative k e to the negative kx times 2 minus xk. Are we cool?
Yep.
Okay, y double at 1 over k is negative k e to the negative 1, 2 minus 1 over k times k. Do we concur?
Yep.
Negative k over e, 2 minus 1. So, times 1. We? Please tell me if k is positive or negative.
Negative.
K is
K
a
is a
fixed
positive.
positive number. Okay, so because k is positive, this is negative or positive?
Negative.
Negative. Y double at 1 over k, our horizontal tangent, is negative. So does that imply that we're looking at min or max?
Max.
A max. If I have flat with concave down, that's a max. Now, you're asking then, how do you prove that to be an absolute max? Yes?
Yeah. I mean,
And the second derivative, I honestly gotta tell you, the second derivative really doesn't do that. So, this is what it should look like. You would say there isn't, actually, let's go back and see if we actually agree. Is that the absolute max? Look at the first derivative here. Before 1 over k, say 0. What's the sign? Positive. And after 1 over k, say k or something like that.
negative.
Negative. Okay?
Goes positive.
So it's positive to negative. Does that prove absolute max?
No.
It can if you're good. Now, when you go to prove this in a rigorous kind of way, you got to use these huge qualifiers, for all, kind of very powerful words in terms of math proof. You would say something like, because I'm not using the second derivative, it just cannot prove absolute. So I'm going to use the first derivative because y prime is negative for all x less than 1 over k. And y double, or y prime is
That's back.
yeah, sorry. Positive for all x's below 1 over k, and negative for all x's after 1 over k. And then we have to worry about, what about continuity? Do you have to talk continuity? I can't remember now. Gosh darn it, I wish I would have thought about that. Okay. I'm going to add in also, because I believe it is important. The derivative goes negative to positive, and it's positive for all x. I'm just going to say it just to cover my butt. And x is, and f, what is it, y? Y is continuous. There's an absolute max at x equals 1. I wish they wouldn't have said second derivative test. It would have been better to make it a first derivative. All right, that's okay. That was a bit of a mess. Sorry about that. I should have probably qualified it or changed it. Questions? Other questions on 72? 14. Didn't I say 3 only? 14. You should U sub it. What's the benefit of U subbing on a problem so simple? It doesn't seem like it's a U sub problem because it's not one is the derivative of the other. Somebody tell me what's the benefit of U sub here? It allows you to see what she's doing with her hands there? Yeah, that's true. U sub, it allows you to distribute in. If you call U x plus 1, then x is U minus 1. That allows you to make this switch of where the root is so that you then can distribute, and you're home free. So that's your U. And then you can work out the rest. Okay, 73. Let's at least get to 73. What do you know? 73. 1. 19. 25. 10.
18
23. 18. 20. 18 and 19.
15 up there.
Wow. Yeah. You would think with that many questions, I would be inundated 7th hour, but it's really just me and Scriptura every day. That's okay. Kish me. You got everything you need right there. All right. Do I need to put a key together? I need to do.
Yeah, we would use the answers.
All right, I'll start putting some. I will start going through and saying what could they possibly be having trouble with, and I'll do those. Of course, apparently that looks like the whole set.
Oh my gosh, what happens to starting?
Starting point.
On the keys.
Okay, guys, did you get your cost equation in number 1? Volume is 432 pi.
Yes.
The top and bottom are made of gold. $8 per square centimeter. And the sides are silver, $1 per square centimeter. Okay. Constant call, milliliters, 2 centimeters. Height is y, radius x. Okay. So, express the total cost. Cost. I would encourage you, if you're having trouble getting started, to start from the general and work to the specific. The total cost would depend on the cost of the top, the bottom, and the sides.
Yep.
Now, when I say what's the cost of the top, it's not just about $8 per square centimeter. I would then need to multiply that in order for the units to work out times how many square centimeters, so I would get cost. What's the square centimeters of the top?
Pi x squared.
Pi x squared. By the same token, 8 pi x squared for the bottom. The cost of the side is $1 per square centimeter. Use the units as your guide. You would need to get rid of square centimeters. What's the cost of the sides, the lateral surface area?
2 pi xy.
2 pi xy. Are you with me?
Yep.
Okay. If if I combine like terms, then I get 16 pi x squared plus 2 pi xy. I drop the units. If you want to continue with the units, you may. They tend to get a little busy for me. It says in terms of x now. So what do I put in terms of x?
Well, x squared times y must be.
Pi x squared times y must be.
Well, you can count on the top.
Gotcha. I see. So y is 432 over. Okay.
So wouldn't it be? Oh, okay, no.
So the equation then is 16 pi x squared plus 2 pi x 432 over x squared, or 16 pi x squared plus 864 pi x to the negative 1. Wait.
Yep.
Wait. Okay. Does that get you started, or do we need to do the calculus?
We need to do the calculus.
I don't think you do. I think you can take a derivative of a power rule. I really think you can. You can.
I don't know.
Okay? So, show some initiative, take it on yourself. This was kind of cool. By the way, I was at CU, and this guy from Ball Metal Company, they did this exact question. You know, the cost of the metal for our can is different on the top and bottom. It has to be thicker on the top and bottom. And he said he did all this calculus, and he came up with the optimum can, and they rejected it. The marketing boys rejected it. And why? Because the optimum can looked like about this, like that. And they said, we can't sell that can. Why not? Because it makes people feel fat. I mean, the can looked like this, and nobody wanted to hold like this. Like it made people say,
I like it.
and then another guy said, that means I'll have to change all the vending machines configurations, every 7-Eleven, it's just not happening. So it got rejected. The optimum can really isn't really used. It's a blend of, hey, what looks good and what we do not have to change things too much. Number 1819. Do I have time for this?
Yes.
The answer is 7. Go.
What?
I'm just kidding.
Oh,
I was like, oh no.
It's my tip. Was part of the problem the intersection points? All right, I'm not going to get through this. There are two methods to finding the intersection points. Remember, the ideas tangents and cosine are meeting, and you want the area bounded by the graphs in the y-axis, not the x-axis, so that's here. Okay? The integrand will be cosine minus tangent, because upper minus lower, they would yield positive heights to the rectangles. The limits of integration. One school of thought is guess and check. Just take a guess. What do you think it's going to be? There's a root 2 in there. I'm thinking maybe a good candidate would be pi over 4. Would these meet at pi over 4? Guess and check works. If you don't do pi over 4, then you have to do something like sine of x over cosine x equals root 2 cosine
Yeah,
x.
that's what I tried to do.
So sine of x equals root 2 cosine squared. Sine of x equals root 2, 1 minus sine squared. So root 2 sine squared plus sine minus root 2 equals 0. It does factor root 2 sine. Root 2 and 1 and positive negative. So sine is... All right, I'll work the keys for Pete's sake and start looking online because we need to get the questions limited here.
Yeah.
Have a nice day.
Yesterday, I think we had. Except you're not. Except I am.